Dr. Ananta M.A., Professor of Civil Engineering Department, Sai Vidya Institute of Technology, Bangalore. Today we will see one problem on static problem by using influence line diagrams. So first it is of module 1 of analysis of determinate structure. They determine the reaction, shear force and bending moment at C for the simply supported beam shown in figure. See, the beam is given A to B. Here UDL is there for 3 meter length. See, the point C is here. So from here to here 2 meter, from here to here 1 meter. Total length is 3 meter. 2 meter one point load is there. This is the load given. So first we will calculate reactions. So for reaction, see this is the beam load given. So for reaction VA we have to calculate. This is the ILD for reaction. Here it is 1. So one UDL is there. We have to project this point. We have to project this point. We have to project this point. Now the UDL is there means we have to calculate this area. If point load is there, we will multiply with the ordinate. Therefore we have to calculate this y1, y2 and y3 from similar triangle property. Y1 divided by this equal to 1 divided by this equal to y1 divided by 7, 1 divided by 8 equal to y2 by 4, 1 divided by 8 equal to y3 by 2. From this I can calculate all the ordinates. Therefore reaction VA equals area average area of this into intensity. Average y1 plus y2 by 2, average height I got, into length. Therefore 0.875 plus 0.5 by 2 into length 3 meter into intensity 20 kilonewton plus 15 into y3. Point load is there, 15 into 0.25. I got it is 45 kilonewton. 45 kilonewton. Now we will calculate reaction VB. Here for reaction VB, see ILD will be like this. Loads are, it is fixed loads, not moving. Therefore below this ordinate, this is the ordinate. This UDL, this area we have to calculate. From similar triangle property, this ordinate and this ordinate we have to calculate. We calculated all the ordinates, y4, y5 and y6 from similar triangle property. Then reaction VB means area we have to consider this height plus this height by 2 into this length into intensity. So I got VB equal to 0.5 plus 0.125 by 2 into 3 into 20 plus 15 into y4. It is 0.75, 30 kilonewton. 30 kilonewton. Now I have to see how to calculate the shear force. How to calculate the shear force at C. See, we know this is the fixed loads. This is the ILD for shear force. ILD for shear force. This is the negative shear force. This is positive shear force. Therefore, this UDL is here. Therefore, this area. This is the negative shear force. This is the positive shear force. First, we will calculate these ordinates from similar triangle property. This is x by L. This ordinate is x by L. This is L minus x by L. Here x means 3 meter because at C we have to calculate at C means x means 3 meter now, because from here to here 2 plus 1, because this length is given 2 meter. 2 plus 1 is 3. Therefore x is 3. L is 8. From this x by L we can calculate 0.375. Again L minus x by L, it is 0.625. This ordinate and this ordinate calculated. From this triangle, similar triangle property, this divided by this equal to y7 divided by this 1 meter. We calculated y7. Similarly from this triangle, 0.625 divided by this length equal to y8 by this length. I calculated y8. Similarly y9 also I calculated. Therefore maximum negative shear force means this area of this into intensity. Therefore y7 0.125 plus 0.375 by 2 into length is 2 into intensity is 20. I got 10 kilonewton. Positive shear means to the right. So this height plus this height by 2, average height, into length is 1 meter. 0.625 plus 0.5 by 2 into 1 meter into intensity 20 kilonewton plus 1 point load is there, 15 into y9 0.25. I got 15 kilonewton. Now I have to calculate bending moment at C. Bending moment at section line. Bending moment at the section. So bending moment at C is, see, this is the ILD for bending moment, already we know, but x distance is 3 meter only. So here maximum ordinate is L minus x by L into x. 8 minus 3 by 8 into 3, it is 1.875. Therefore, from similar triangle property, this triangle considered for calculation of y11, this divided by this equal to this divided by this length 1. Similarly, this triangle is considered for calculation of y11 and y12 from similar I calculated here. Again, after calculating the area of this will be considered into intensity will give you the load at contribution of the UDL. Then this vertical load into this vertical distance will give you the point load contribution. Therefore it is, first I am calculating this area. Y1 is 0.625, 0.625 by plus 1.875 by 2 into 2 meter into intensity 20 plus right side 1.875 plus Y11 is 1.5 by 2 into 1 meter into intensity 20 kilonewton plus 15 into Y12, 15 into 0.75, I got 75 kilonewton meter.